Hello and welcome to this AI Sprint demo. My name is Patrick Thiem. Let's get right into it. Before we start, I will give you a short overview of what this demo will show. You will see the interaction of several AI Sprint tools, namely Infrastructure Manager, Krake, PyComps, and Space for AI-R. And there are also other tools involved like MinIO, Kubernetes, and InfluxDB. The process itself will be like this. First, PyCom's application is scheduled on a Kubernetes cluster using Krake. Second, I will manually trigger a rescheduling process in Krake by changing some metric values. Third, the PyCom's application will be migrated from one cluster to another in a stateful way, meaning it can just continue where it was interrupted. And last but not least, after the migration was done, the app runs until it has finished. Now some further details about the demo to better understand what is going on. The migration itself is initiated by a change in metrics, like there is more renewable energy available somewhere else. Space for AI-R ensures that the application, even if migrated, finishes in a 1-hour time goal. For this demo, we have chosen a smaller accelerated training process. In real scenarios, it could be multiple hours or even days. If not interrupted, the PyComps application here in this demo would finish in about 50 minutes on the initial cluster. Migration comes with delays, like up and downloading or VM creation. Space for AI-R accounts for these time losses so that the 1-hour goal can still be met. In the top left, we can now see the structure of the setup in a graphic. Throughout the process, it keeps changing. Several components are initially there, like Krake, AIM, the cloud sites, and the initial Kubernetes cluster, etc. Here you can see the metric generators of cloud site A and B. There, I will manually initiate the change in metrics to trigger the rescheduling. Right next to it is the MinIO panel, where we will see the PyComps checkpoint files. Below that is the main Krake panel, where the app will be scheduled and observed. On the left, we can see the clusters registered in Krake, and above that, the PyComps application logs. I also added a little stopwatch to track the time. Now let's create the PyComps application with rock-kube app create, the shutdown hook flag for stateful migration, and the auto cluster create flag in order to let Krake create a new cluster on Cloud B. I also start the stopwatch and the tracking of the PyComps logs. And I also activate the watcher for the PyComps app in Krake. There you can see that it is currently running in cluster 1. The video will now be sped up until we reach the 7-minute mark. Have a look at the stopwatch. In order to trigger the rescheduling mechanism in Krake to migrate PyComps to Cloud Site B, I changed the green energy ratio metric. I raise it in Cloud B and lower it in Cloud A. You can see the change in the diagrams as well as in the score. After some seconds, the PyComps process in cluster 1 is killed and the upload process of the checkpoint files starts. Once the upload is finished, Space for AI-R calculates how many CPU cores the new cluster should have based on the PyComps logs. Krake gets that information, inserts it in the cluster creation file, and AIM creates the cluster and registers it in Krake. That takes about 10 minutes. As soon as the cluster was created, Krake places the PyComps application on the new cluster. The PyComps pod downloads the checkpoint files, which again takes about 10 minutes. After that, PyComps continues the training and runs until completion. That's it. In the logs you can see that the execution has been finished. This is the end of my demo.